I'm Pete Klusky. I'm a Senior Manager for Mitsubishi Power Systems Europe. We're developing a very exciting project for the next generation of offshore wind turbines.
I'm Andrew Donaldson. I work for SSE. I'm SSE's Offshore Engineering Manager. We will manage the build of offshore wind farms, and then most importantly, we will generate the electricity from those wind farms.
My name is Pete Nellaney. I'm a Project Director. I work for Technip Offshore Wind Limited. Technip Offshore Wind is a subsidiary of Technip, which is a global construction company.
My name is Dominic Getting. I work for Wood Group Renewables as a project engineer. Our contribution to the overall project will be to deal with the substructure of the programme and also to look at installation, health and safety and operational and maintenance issues.
There's huge potential from the wind resource around the UK to develop very large projects, but they're in deeper water further from shore, and we need a more specific technology that's right for that application.
A number of sites around the coastline offer fantastic wind speeds and relatively uninhibited issues with regard to shipping.
The only limit on offshore wind is the ability of the supply chain to get the cost down to the point where it is economic for us to invest in projects.
Efficiency is the key to success. Efficiency in design, efficiency in development, efficiency in deployment, efficiency in operation, and ultimately efficiency in decommissioning.
If we can get the cost down, I can see no limit to the projects that are open to be built. We embarked on a journey probably 3 years ago now of setting up alliances to deliver offshore wind projects.
At an early stage, as an inward investor, we talked to BIS and we understood how they could help us to bring this project, which was a mobile international investment project, to the UK. It could have gone to Germany, it could have been done in Japan, but by working with BIS at an early stage, we were able to develop a really good, exciting programme.
The alliance is special because it brings together world-class organisations, large corporations that have got a lot of experience.
Technip will bring to the offshore wind programme our experience in offshore contracting, including our construction business, our subsea cable installation business and the protection of those cables.
Expertise in shipbuilding, manufacturing, volume manufacturing of hydraulic equipment.
We're willing to put some groundwork in now at an early stage so that we can understand how we interface together and how we can build and design the best equipment.
And we do start with a strong history of engineering skills on the back of the development of North Sea oil and gas in the 70s and 80s. Those skills are still there, a very highly sophisticated supply chain operation, much of it in northeast of Scotland, but also on Tyneside and elsewhere. And we want to achieve a transformation and incorporate the offshore wind sector into that and graft it onto it and draw on the skill base.
Digital hydraulics began with the requirements for wave energy. Back in the 70s, we found that all the existing conventional hydraulic machines would not be powerful enough or efficient enough over a wide power range to do what we needed. And so we came up with the idea of controlling them digitally rather than with the old analog way. So we realized then that it could be used in lots of other things: road vehicles, wind, tidal stream. And it's taken a long time to get there, but I think it's really happened now.
What Wood Group is going to develop for this project is a very cost-efficient substructure. What we're trying to do is design that in such a way that it complements the design of the turbine itself, so it's all in harmony with each other, so that, for example, the dynamic response of the turbine is tuned to the way we design the structure itself. And then the second part of it is designing so that it can be manufactured in mass rather than be a one-off fabrication structure, which is more typical for the type of structures that are installed in the North Sea just now.
In terms of Technip, we're looking particularly at the installation techniques for offshore wind. We're looking at the way that wind turbines can be carried out on vessels out to sea and installed safely and quickly. But also then, well below the sea level, we're looking at the way that cables are installed. the cables that connect the wind turbines together and then connect the wind farm to the shoreline. And we've got some technology in that already and investing in research and development and capital plans for that particular aspect. And that's an area we see massive improvements being made in terms of this programme.
Part of our journey on this exciting programme has been how we develop the specific turbine technology, and we're really excited to be able to work with Artemis. It's a company that we acquired in December 2010, and they have fantastic novel technology that you see behind me, which will help to produce very reliable, very robust and easy to maintain wind turbines.
At the front end of the wind turbine, the visible part of it, you're trying to capture power depending on the varying wind at a varying speed, a varying very slow speed. At the other end, you want to turn an electrical generator very, very fast at a constant speed.
We're developing a transmission that is very much bigger than any previous hydraulic transmission, very much more efficient than any previous hydraulic transmission. It's computer controllable. It's essentially an extension of technology that we've already developed for car transmissions, but now going up into the megawatt scale.
And because we're using synchronous generators, the power quality is better than any other turbine that's out there. Even if it loses one small fraction of its capacity, it can carry on working. And that means that we don't have to pay for an expensive service visit. We can carry on working even if one of our components has gone down.
If the technology is proven, it will give us an effective offshore wind installation programme which will be industrialised, the cost will be optimised. So getting this programme started at this stage is a fantastic opportunity for all the participants.
It is going to create a focus for an offshore wind turbine, and that focus should allow a whole supply chain to become involved in the offshore wind industry.
Once we have established it in the UK, then there are many international possibilities for this technology.
That's why we have established very recently the UK Green Investment Bank. It's designed to act as a catalyst for private sector investment and to finance the green technologies as they emerge.
The wind will continue to blow for generations to come. So as long as we put equipment in place that can collect that wind, then the fuel will never run out.
Hopefully we'll be able to build an industry around this technology that will inspire young people for 20, 30 years to become engineers, to become project managers.
It's a way of getting as much of our energy as we can from nature, and there's nothing more exciting as an engineer than to do that.
It's quite heartening for us, having done this, that we see that the recent DEC report on cost reduction in the offshore wind industry has tapped into what we've been doing. So we're really very pleased and very proud that we've created something here that, if you like, is ahead of the pack.
This project is a lot bigger than I ever imagined then. Perhaps we were thinking too small at the beginning.
And the more challenging the project, the more satisfaction there is when we reach the end point.
We're really looking forward to seeing a Mitsubishi turbine on test at our test site in Hunterston.